Hi guys, welcome back to my channel. So in this video I will show you guys how you can do the addition and the subtraction of the unsigned numbers. Okay, so for now I will only focus on the unsigned number because I want you guys to know the concept, like how it actually works, the addition and subtraction of unsigned number in binary. So once you guys understand how the concept works, so in the next video I will show you guys how you can perform this with the signed numbers. Okay, so for now we're only focusing on the unsigned numbers. So we have these two numbers given and we want to add them, but we want to add them in binary. So to do this you need to go back into elementary school. Remember, like in elementary school, if I would ask you guys to go ahead and subtract to do the addition of these two, so how you would do this, you would write like 24 plus 22 like this, and then you would do the addition like this, right? So you would do like 6 and then you put 4. So this is how you would do it in elementary school. So just like that you're going to do it with the binary numbers. Okay, so you have 1 1 1. Now you're going to add it with 0 1 1, and now remember you are doing the addition in binary now, okay, not in decimal. So 1 plus 1, that's a 2. But what's 2 in binary? 2 in binary is 1 0. Okay, 0 1, that's a 1 in binary, 1 0, that's a 2 in binary, and 1 1, that's a 3 in binary. These three you guys have to know. Okay, the rest it doesn't matter, you can always do the division to figure out the number, but these three you guys have to know. Okay, so 1 and 1, that's a 10 in binary. So what do? You put 0 here and you put 1 at the top, right? Just like how you would do in the elementary school if you had, like, for example, here 6 and 4, so you would put like 0 here and then 1 at the top over here, right? So just like that we're doing the same thing. And now this becomes 2. Okay, so this is 2 plus 1, that's a 3 in binary. So what's 3 in binary? I just showed you guys, this is a 3 in binary, 1 1. So you put 1 over here and then 1 over here. Okay, and now this becomes 1 plus 1, that's a 2. And how do you write 2 in binary again? So you put 0 and 1 here, so there's nothing over here, right, with the carry, so you simply put it over here. Okay, so this is going to be your final answer, but this is different. Okay, you cannot go ahead and, since you don't have any number over here, right, so you cannot put like hanging carry over here. Okay, so in this case you cannot do this because computer has only 3-bit register to store the data. Okay, so the maximum number that you can get is only 3 bits, so you cannot get 4 bits. Okay, so here, even though you get this 1 over here, you're going to call it overflow. So this is the case of an overflow, and your final answer you're just going to report it as this one. Okay, so like only 0 0 1 0, which is a 2 in binary. Okay, so this is going to be your final answer. Why again? Because you can the computer can only store, the computer has only 3-bit register to store the data. Okay, so only 3 bits would be stored, so only like 0 1 0. The 4th bit you're going to ignore it since it's an overflow. And again, I can explain this concept again. This is just like elementary school. 1 plus 1, that's a 2 in binary, so 2 in binary is 1 0, so you put 0 here, 1 over here, 1 1 1, that's a 3 in binary, 1 here and 1 here because this is 3 in binary, and then this is 2 in binary, so 0 here, 1 over here, and 1 0 1 0. That's your final answer, but you won't report it as it is. You're only taking 3 bits because you have 3 bits over here, so 0 1 0, which is 2. So this is your final answer. Okay, now let's move on to subtraction. Okay, so let's go ahead and do the 7 base 10 minus 3 base 10 in binary. Okay, so here you guys see you have in base 10, but you want to perform the operation, the subtraction, in binary. So first of all you need to convert these numbers into binary. Okay, and like I explained in my previous videos, if you have something given in base 2 and you want it into a different base, binary means base 2, right? So you have something in base 10 and you want that into base 2. So how you would do this? I already explained this in my previous video. You guys don't remember, so let me recall. So you're just going to, since your answer is already given into base 10, you're simply going to divide it by the base that you want the answer to be in. So 7 divided by 2, okay, and then this is gonna be 3, because 2 times 3, right, that's a 6, right? So, and then the remainder, since you get a 6, so 7 minus 6, that's a 1, so you get remainder 1, okay? So, and then the number that you get over here, you're going to divide it again. So you're going to keep dividing this, the number that you get over here, by 2, and until you get a 0 over here. As soon as you get a 0, you stop, okay? So then 3 divided by 2, so you get 1 remainder 1, right? Because 2 times 1, that's a 2, and then since it's a 2, the remainder that you're gonna get is 1, okay? And next we're gonna divide this number, 1 divided by 2, which is 0, right? And then we have the remainder of 1. So you got 0, and then the remainder that you had because of the 1, okay? So then the number that you write, you're going to start it from here, 1 1 1, and you're going to look from the top and then start writing the answer from right to left, okay? So you have 1 over here, you put it over here, 1 over here, write it over here, and then 1, okay? So you always look from the top and write the answer from right. Okay, so once you have this, so this means this is 1 1 1 in base 2, which is 7 in binary, okay? So you have this number over here, 7 in binary, which is 1 1 1. Now you have to convert this in binary. This you already know it, right? 3, which is 1 1 in binary, right? So now you can perform the operation. So you have 1 1 1 7, and you need to subtract 3 from it. 3, which is 1 1 in binary, okay? So just like how you would do in elementary school, this is how you're going to do it, right? So 1 minus 1, that's a 0. 1 minus 1, that's a 0, and here there's nothing, so this one just simply comes over here. So this is 100, which is 4 actually in decimal, like 4 to base 10. So this is 100 to base 2, so this is your answer if you do in binary, right? It does make sense, because like 7 minus 3, that's a 4 in decimal, so you can actually convert this into decimal to verify your answer. So let's go ahead and do another example, but with a carry, okay? So you have to do this, but again in binary. So your first step is to convert to binary, and I guess at this point I don't have to write the step, you guys know it, right? So 9 base 10 in binary would be 1 0 0 1 2, okay? And 5 base 10 would be 1 0 1 2 in binary, okay? So now you have to do this, 9 minus 5, so 1 0 0 1 minus, this is just base 2, okay? You write it or not, it doesn't matter, okay? And 1 0 1. So now 1 minus 1, that's a 0, okay? And then we have 0 minus 0, that's a 0. And now can you subtract 0 from 1? No, you cannot do this. So what you have to do, you have to take a carry from the other number, okay? So for example, like in elementary school, if you had like something like, let's say 4 and 2, and here you had like 6 and you had 1, okay? So here, since you had 6, can you do like 2 minus 6? No, you have to take a carry, so this becomes 3 and this becomes 12, right? So now you can do it. So just like this, you're going to take a carry, so from the neighbor, so this becomes 0, okay? And then this, so just like there, it became 12, right? Not 3. So here 1 0, so it won't be 1, it 1 0, that's a 2 in binary, so it becomes 2, okay? So you need to treat it as 2. You're not going to take it as 1, okay? So 1 0, that's a 2 in binary. If this is confusing to you, so you can actually go ahead and put 2 over here, right? Instead of writing like 1, So simply write 2, so it's simpler for you guys. Okay, so because I always prefer to write it over here like in decimal instead of binary, because it's easier for me. Because like if for example here we had like 1, for example if we had like 1 over here and we were taking another one over here, so 1 1, that would become a 3 in binary, and sometimes I just confuse myself, is it 3 or not? So I would prefer to write 3, so I know, okay, so this number is actually 3. So okay, so moving back to our original example. Okay, so now we know that this is a 2 in binary. Okay, so 2 minus 1, that's a 1. Okay, so our final answer becomes 100, which is again 100 base 2, or you can say 4 base 10 if you convert it, right? 4 base 10. So if you do 9 minus 5, which is a 4, so your answer is correct. So now this was it for the unsigned number. And this is not how numbers are actually represented. The numbers are always represented with a sign and magnitude. Okay, so like for example, if you want to represent -7 base 10, okay, so you're going to write like 1 1 1. Okay, but then there's another 1 over here. Okay, so this is how you're going to represent it. Why? Because this thing that you see over here, this is magnitude, which signifies 7, but the first one that you see, this means negative. Okay, so this is the sign. This is why it's called the sign number, because the numbers are always represented in the sign and magnitude. Okay, so the first one that you see, it's gonna be sign. If it's 1, that means it's a negative number. If it's 0, that means it's a positive number. Okay, and the rest is the magnitude. Okay, so in the next video, let me show you guys how we actually perform the sign, the subtraction and addition with the signed numbers. Okay, so see you guys in the next video.